F, uh, t, the, Hello, today is quite an unusual video. I planned this video a lot of time ago, but since I have hit 4,000 subscribers, I have decided to finally do it. So this is a physics paper, mechanics specifically, and I will try it even though physics is not exactly something I'm very good with. So let's begin. First problem, we have two particles of masses 1.8 and 1.2 kg connected by a light and extensible string that passes over a fixed smooth pulley. The particles hang vertically. The system is released from rest. Find the magnitude of the acceleration of the particles and find the tension of the string. Alright, so we have a pulley. We have a rope going through this pulley. And we have two objects. The first one and the second one. This system is pretty much symmetrical, so let's assume that the mass of the second object is greater than or equal to the mass of the first object for convenience sake. So what forces do we have? We have this force, m1g, and clearly translates impulse here. What we can do next is we can work with the entire system, defining the force for it, and saying that the mass of the entire system is the sum of masses of those two particles. Next, you can say that this force is going to be equal to m2 minus m1g, as that was pretty evident, and you can represent acceleration in terms of m2, m1, and g. It's going to be m2 minus m1 over m2 plus m1 times g, and the tension is going to be F. Well, I hope I know what tension is, because I have never studied it rigorously, or in any way at all. This is my first time seeing tension. So this is the acceleration. I will not calculate it. I don't have this much time, sorry. Particle of mass 1.5 kg starting from the rest of the day, slides down and climb point A, B. Point B is 12.5 meters vertically below the level A as shown in the diagram. Okay, part A. Given that the point is smooth, use an energy method to find the speed of the particle at B. So we can just ignore the friction because the surface is smooth. It's negligible. So let's call this H. We have mass, let's go with M. And let's write down this energy conservation equation. Now the height we end up at, the potential energy is going to be 0. So let's find the potential energy here. Let's call it mgh. Okay, and v squared is going to be 2gh. So v is going to be equal to square root of 2gh. This given instead that the plane is rough and the particle reaches B with a speed of 8 meters per second. Plane is 25 meters long, and the constant frictional force has magnitude F newtons. Alright, now let's work with this. My current idea is to find the difference in energy and then say that that work has been done by friction. So let's go ahead and do this. Let's call that A because that's work done by friction. That's what was lost in the process. And this work is going to be 25 meters because that's the length of this thing so we were given. Times A is going to be equal to times F is going to be equal to A. So F is going to be equal to A over 25 meters. The next problem. 3. Coplanar forces of magnitude 52N, 39N, and P and act at the point in the direction shown in the diagram. Well, Newton's, I should have pronounced that properly. Shown in the diagram, the system is at equilibrium. Find the values of P and theta. Well, they're coplanars, so let's define the coordinate system y, x, and let's define z as the cross product of them, I suppose. 39 squared plus 52 squared. Take the square root, and that's gonna be the length of this vector, and this vector has to cancel it out. So they're supposed to be opposites, so they're gonna have the same magnitude. Now we need to find the angle of it. With what? This thing is gonna be equal to what? Well, we know for sure that the tangent of theta is gonna be equal to this is negative 52 over negative 39. So 52 over 39. And we can say that theta is equal to arctangent of 52 over 39. Okay, that was fairly simple. Next. A bus travels between two stops A and B. The bus starts from rest at A and accelerates at the constant rate of 8 meters per second squared until it reaches a speed of 16 meters per second. It then travels at this constant speed before decelerating at the constant rate of 0.75 meters per second squared, coming to rest at B. The time for the journey is 240 seconds. Sketch the velocity time graph for the bus journey from A to B. Alright, this is gonna be troubling, I suppose. So let's say that here we have 240 seconds. So let's call this 16 part. Okay, a second is implied here, so I can just remove it. Otherwise it will be second squared, not something we want. So starts at rest and starts accelerating with A. So it hits 16, then travels at its constant speed before decelerating at the constant rate, coming to rest at B. Okay, 0.75. So the slope here is gonna be lower by the absolute value. Okay, so we need to find this time over here. What we need to do is we can just subtract this interval and this interval. So how long does it take for it to accelerate to 16? Well, it's gonna be just 16 over A, and that'll be this part. How long does it take for it to decelerate with this acceleration? Well, 16 over 0.75 A. So 16 over A times 1 plus 4 over 3. So is equal to 16 over A times 7 over 3. So 112 over 3A. It can be this intermission. Next, what we have to do is subtract it. So 240 minus 12 over 3A is this segment over here. Let's call it delta t. Alright. Given that the distance from A to B is 3000 meters, find the value of A. Well, alright, let's work with that. acceleration. I didn't need to show anything more than that. Okay, now fifth part. Total we have 8, I think, yeah. Alright, particle A is projected vertically upwards from point O, speed of 80 meters per second. 1 second later, the second particle B with the same mass as A is projected vertically upwards from O, speed of 100 meters per second. Then T, after the first particle is projected, the two particles collide and coalesce to form a vertical C. Sure, I suppose. Vertically upwards from point O with a speed of later second particle with the same masses. A is projected vertically upwards from O with a speed of 100 meters per second. Two particles collide and coalesce. Okay. XA of T is gonna be minus GT squared over 2 plus 80 meters per second T, and XB of T is gonna be equal to 1 second later. Okay, so minus G. Next we include T minus 1 squared over 2 plus 100 meters per second times T minus 1. Alright. 2GT minus G over 2 plus this part is equal to this part. I think so. Alright, now GT minus G over 2. Alright, now plus 100 meters. Okay, yeah, here we lost the unit. Holy yap, this is terrible. Plus 100 meters. No, it's yeah, minus 1, that's minus 100 meters. And then we subtract 80 meters per second times T from both sides. We have plus 20 meters per second times T is equal to 0. And well, now to extract T, we just bring it appropriately. So first G plus what? Okay, that is terrible. Yeah, while doing algebraic manipulations here, I lost the second unit. Right, this is so stupid. I hate physics for this. G times 1 second plus 20, or wait, not, 20 meters per second is equal to what? Is equal to G times 1 second over 2 plus 100 meters. Next we can divide both sides by this expression, and what we get is some terrific manifestation of my hatred to physics. Alright, that's the time. Now we need to show that that is equal to 3.5. Do I have to? Right, let's do some basic calculations. Let's say that g is equal to 5. Not 5, 10. So 5 plus 100. I'm not gonna bother with units. Sorry. Not sorry. 10 plus 20, so we have 105 over 30. So we a little over 3. So 3 plus 15 over 30. So 3.5. Alright, checks out. So 3.5 seconds. Find the height of O at which the particles collide. Well, I can just plug this into this equation, so I won't even bother to do any tricky operations here. Let's just feed it in the thing. Alright, find the time from A being projected until C returns to O. The two particles colliding coalesce to form a particle C. Does coalesce specifically mean? Okay, I just googled. This is pathetic. They form one body with a emergent mass, so the new mass is going to be 2m. Momentum is going to be x a 5 prime times m plus x b prime of 3.5 times m. So m times x a prime 3.5 plus x b prime 3.5. So this basically implies, considering how the new mass is 2m, that the initial speed here from the point where they collide is going to be the average of the speeds they were colliding as. Okay, and what else do I need to know? Find the time from A being reaching until C returns to O. So xc of t. Now the t measurement is a little bit different. It's starting from another point of collision specifically. So we have to solve this quadratic. Gt squared over 2 minus b0t minus xa 3.5 is equal to 0. Now look how the torque coefficient is negative, therefore one of the solutions is going to be negative. So we only look for the positive one. So t is going to be equal to v0 plus square root of v0 squared minus 2g minus 2g times not minus plus 2g times xa at 3.5, and we divide all of that by g over 2, so divided by g. Okay, no, let's just multiply this by 2 over g. Okay, you know what, I'm tired for today. This was terrible. I hope it wasn't too terrible. That's it for today. I might do some other problems from physics. Thank you for watching. Bye.